Ooh. Hello YouTube and good morning. Got myself a parcel all the way from Bulgaria this morning. So let's open it up and see what's inside. Very well wrapped. It's 2 items. There we go. And this is it. This is a custom built microcontroller and OLED module called an OLEDiScope. It's the creation of a YouTuber called Hayri, who I've been speaking to over the past few months. I'll leave a link to his channel up in the cards above at the end of this video, and I'll leave a link to his channel in the description below. I recommend you go check his channel out. So Hayri is a maker who's based in Bulgaria, and he makes all these small modules based around the Atmel 328p microcontroller, and he usually connects these small little Chinese OLED displays, usually piggybacked onto them, and he sells them on his Tindie Store, which is called Phoenix CNC or Olediuno store. Again, I'll put a link to his Tindie Store in the description below. Check it out. It's got all sorts of cool little modules, little electronics, gadgets, gizmos, lots of geeky cool things. Highly recommend you check it out. So he left a message on one of his videos that I was watching, basically asking if anyone was able to help him with a 3D printed case for one of his modules.
If anybody wants to design a 3D enclosure for this, let me know, and we make a deal.
So I got in contact with some help with my 3D printing knowledge, and we've been talking ever since, talking about his OLEDiScope, his Olediuno projects, various electronics, 3D printing, SMD, soldering, toaster ovens, print and place machines, all sorts really. And that leads us on to today, which is receiving this OLEDiScope through the post. This is a tiny functional oscilloscope using the Atmel 328p chip, and the results are displayed on the OLED screen. Now this is a new version. The one he sells in his store only has 3 pins. On the out it has voltage in, ground and a signal in. But if you can see on this one, we've actually got 4 pins, and one of them is actually a signal generator. So as well as a oscilloscope, it's also a frequency signal generator, which is pretty cool. All in this tiny package. Now it does actually have a 3D printed case for this because it's so tiny, and I've gone and printed out one of his versions already, which you can see here. I printed out in green, filamentive green. Oh, actually I've got a time lapse for you, so oosh. Why do I keep clicking? Yeah, done in filamentive recycled PLA green. It's just what I had to hand. I've got lots of it. I only needed it for a little project, so I'm just using it as a prototype. This case does not fit because of all the changes in his PCB. The existing case, it's slightly misaligned, and you've got the 4 pins instead of the 3. You've got a little hole at the bottom. Show you the front. And on the bottom, if that focuses, it's not big enough. And there's a few other little design changes on the case that I'd like doing. It just friction fits together, so I'd like to make some snap size for it and just improve on it. But what Hayri does like are these little oscilloscope wavy line things. That's one part of the design he does like, which is where I come in, and I'm going to redesign this case and try to improve it. Now I'm going to use Fusion 360 to design a new case for the OLEDiScope, and and get Hayri to print it out. I might even send him a few examples with some improvements. And if Hayri's happy with that, he's got some other modules that he'll probably send over, such as the OLEDiScope, the OLED trick. Again, check out his Tindie Store. It's really cool. But yeah, they're very fragile little things, so all of them kind of need a little 3D printed case. So that is the plan. Along with the OLEDiScope, he sent through a few little PCB designs. This is something relatively new he's done. It's a PCB frame. You buff it up. Hopefully you can see that and it won't focus through my hand. So this is for one of his modules. It's the OLED GPS. So it has a GPS module attached to the Atmel 328 and the OLED screen, and it tracks your speed and GPS coordinates and all that fun. And then if you turn it around on the other side, it is just blank. So that gives it a real cool looking display. This is actually for the 1.3 screen. You can see it's a bit big. So that's a larger one. The standard ones, these are the 0.96 inch screens, the type you get on AliExpress for 10 a penny at the moment. And looking closely at this one, I think this is a blue and yellow because there's a little line, so we'll see. So future projects will be to create some kind of little wrap case or like a little bumper case to go with these modules as well. So I'm going to have a play with this now and see how it works, see how the oscilloscope works, see how the signal generator works, and have a general play with it before I create a case. Hopefully don't break it or do anything dodgy to it, so you have to send me another one. So yeah, come a bit closer and we'll have a look. So there's the front side, you got the OLED screen, and then look on the back, which is actually the front of the PCB. You can see the Atmel Atmega 328. This is a little rocker switch, which is what's used for navigation. There's various circuit boards. So it's this little square PCB, which is Hayri's main, what does he call it, an Olediuno type board, and he uses this for all these various modules. And he's basically soldered on an OLED screen in reverse, so you get this very thin, insanely thin design, which is a fully functional oscilloscope, and now he's also got it as a signal generator. So we'll have a look at the oscilloscope, see it in action. This kind of kit is ideal for if you just want to hook up a oscilloscope to one of your projects just to see what's going on, see if you've got the right signal, see if you've got the right voltage. If you can't afford a fully fledged oscilloscope or one of those DSO ones, this is a really good solution. You just pop it in your bag and take it with you in case you need it. I'm going to throw it in one of his old cases just to protect it, and just so my grubby fingers are not going all over the circuit board. I'm sure that will affect it a little bit. So this case just snaps in. There we go. Looks pretty snazzy, really. I do quite like the green. Came out really well. So to hook this up, you need, remember, yeah. So you need ground. You need power, and then your input line is this middle one. So we've got a Arduino on a breadboard. It's running a basic sketch. I've got a red LED, a green LED. These are really cool. These are 10mm LEDs, and they're pretty crazy looking, but they're really good for video demonstrations. Get a great big chunky LED. They come out well on camera rather than using little small ones. So one of these LEDs will blink and the other one will fade, so we'll be able to see a solid signal, and we should be able to pick up the PWM signal because it's using PWM to fade. So let's just plug it in. So there we go. The sketch is running. The red light, which is on 13, is blinking, and this green LED, which is on pin 9, is fading using a PWM signal. And the oscilloscope is turned on. So basically using this little rocker, I'm not going to use a frequency generator, but you go into that and you can change the signal, you can change the hertz of the signal, and it will generate a signal. So just pull the power on that. We're going to go into the oscilloscope. Varying signal at the moment. I've had a little play already, just adjusting some of these parameters. Hitting the button that goes along the top, you can change various settings. This one is a time base. I found 2 seconds gives you a good signal. The P there is a pause, you can actually pause it. So just leave it on there. It's showing up 5 volts. This is your input pin, just a standard breadboard pin. So if we connect it to pin 13, you can now see the oscilloscope is doing something. It's going low and high between 5 volts. You can see the signal there, it's going between 0 and 5, and if you match it with the LED, you should see that it's going on and off as the LED is going on and off, which is what the microcontroller is doing. Pin 13 is going high and low, high and low, and this oscilloscope is detecting it. That's a real basic example, really good. We now try the PWM signal, put it into pin 9. There we go, that's a lot more interesting. You have to excuse the refresh rate on the screen. Those lines are just there because of the camera. But if you watch the PWM signal, as the LED fades, the PWM signal gets shorter and longer. So when it's maximum brightness, the PWM signal is the highest. If that's the right word, highest, longest. That's a really cool setup. I'm not gone too much into the actual code and the setup of the oscilloscope or the function generator, but it's a real handy little tool. It's really tiny, and I can't wait to create some new cases for HAY-REE, and then hopefully work on some extra projects. Again, go check out his store on Tindie. He's got some really cool gadgets and little things that you probably didn't think you need, but when you look at them you think, wow, cool. So if you've enjoyed this video, don't forget to give it a thumbs up, and if you haven't subscribed, please do so, because the subs matter a lot now. So don't forget to hit subscribe, and don't forget to hit the little bell so you get notified when I update with new videos, which are a few and far between at the moment, but they're going to be increasing as I hope to improve my YouTube channel and my YouTube stats to get back in bed with YouTube. And if you've made it this far, thanks for watching.